could be really rough. Throw your hands up in the air and say enough's enough. Do you want to learn to code and make some awesome stuff? Learn that anyone can when you're coding with Dan on. Whether you're a pro or this is all brand new, learn the overarching concepts and some fun stuff too. And with Dan as your guide, come along for the ride on.
Oh, hi! I totally screwed this up.
Make a crazy pixel mirror to reflect your face. You can make it jump to light speed into outer space. You can generate a maze that can go on for days. You can make your own terrain and some purple rain. You can make a retro game to see how it's done, and then tweak a piece to make it yours for everyone. Make some fractally trees or Twitter bots if you please. And when the seeds are all sown, you can make them your own.
Whoops. Hi, it's the coding train with an echo.
Ride the colors of code, you can follow the road to.
Hello, welcome, good morning. Oh, no, wrong. I don't have my buttons down. Hello, welcome, good morning. Let me lower this down here. Move my, I brought some train toys in for a bit, a little shtick that didn't work at all. Now I gotta turn off that monitoring. How are you guys doing? This is the Coding Train, a weekly live YouTube thing where my name is somebody named me. Name isn't me. The name is Dan, which is me. Comes to do some tutorials and make some projects and some challenges around code. So what I always like to do, just to set the mood and relax a little bit at the beginning of each episode, which I think I've only done once, I'll probably not do it the next time because this will be a disaster, is I like to continue a little bedtime story. And if you recall, in previous Coding Train, I read page 1 of a little bedtime reading book that I like to call, well, I don't like to call it, I mean I do call it, it is the title, A Million Random Digits with 100,000 Normal Deviates. So we will continue where we left off last time. On page 2. 9,188. 20,097, 32,825, 39,527, 4,220, 86,304, 83,389, 87,374, 64,278, 58,044. I know that for many of you, for me it might be 11 a.m. here on the East Coast of this country in New York City. For many of you, it might be late at night, and I wish you, please go to sleep, turn this off. I don't know, I gotta workshop that some more. You know, I need some more practice. I need to put some more thought into that. Hopefully you enjoyed that. Welcome to the weird side of the internet is true. Okay, so, oh, you want the noise digits, yes. Okay, so let's see, what do I have to say for myself today? It was a snowstorm yesterday in New York City, if you can believe this. New York University was closed. We're lucky, or unlucky, I'm not so sure just yet, that NYU is open today, so I was able to come here to my studio. I am now making a commitment to do this every week. I would like to say at 10:30 a.m. is my planned start time. As you can see right now, it is about 11 a.m. East Coast time, so it often takes me a little bit longer to get started. And then I have this thing that I do which I ramble on and on and on, so you might as well just wait till around 11:30, where I hopefully, but I'm going to try to just jump right into some coding topics and stuff today, because I have a lot of things I would like to do. I see that there are people in the chat. It seems that everything is working. You can hear me. I have my soothing ginger tea. I have my water. Coding Train, brought to you by water. Stay hydrated, everybody. Okay, and then I have this thing where the camera shut off. I don't know about this train whistle. I've been getting some negative feedback about the train whistle. So let me put my train toys away. This is, who is this? Oh, this is the express train. This is Rosie, my favorite train. This is Annie, another train that I love. And this is Rheneas. Pilfered from some children's, my own children's bin of train toys this morning on my way to work. So I have, so let me just, in case anyone's wondering, mention a couple things. You can find out everything you want to know, perhaps, at thecodingtrain.com. That's the URL. Please, if you like what I'm doing here, subscribe on YouTube. You can also become a patron. By becoming a patron, that's a crowd uses a service called Patreon, and then you'll get an invite to a Slack channel that I also will look at. I try to keep an eye on the YouTube live chat as well as the patron Slack chat to answer questions and get feedback, because basically I just make constant mistakes, get stuff wrong, and then the internet helps me out. Okay, so that's the other thing that you can do a lot of times is that what I'm curious about, I've mentioned this before, most of the stuff that I'm doing now is programming tutorials and coding challenges, and the assumption is that the people watching this particular content already know something about programming and coding. But I do have two sets of tutorials that are completely and entirely for beginners with no experience whatsoever. Just to mention this one, which is Foundations of Programming in JavaScript using P5JS. And then I also should mention I added a video to that called P5JS with brackets for beginners who are looking for a code editor to use. So if you know somebody who's thinking about learning to program, who's interested, and you think that they might benefit from my videos, that's something I would love for you to do, is share with beginners, because I know that sometimes I get the feedback, beginners find my channel, and they're like, this seems interesting, I like it, but I don't know what's going on here, and I have to put a little reminder of where to start. So maybe I need a better way of doing that, but that's what I ask you, the internet, to help me with. Okay, so that's my opening spiel. The other thing that I have is I have this, whatever. I have this Google Doc now so if you would like to give me a suggestion as to a coding challenge idea or ask a question that I might answer on a future live stream, certainly you can sign up for the patron group, but I also have here this GitHub repository, codingtrain/rainbow topics. This is a GitHub issues. These are the GitHub issues you can file. All you have to do is come here and click new issue, and you can submit your idea there. What I do then during the week is I kind of look at this GitHub page, look over it, keep track of it, and then I kind of organize things that I'm thinking about and ideas. And for some reason, I just woke up this morning feel like I wanted to do an earthquake data viz challenge. I know, like, nobody suggested that. It's not even on my list of stuff that I thought of all week that I would like to be able to do today. But for some reason, it felt like the thing to do. So this is a running list of stuff that I'm considering doing today. Before is my t-shirt, I'm getting a message in the Slack chat that my t-shirt is a bit transparent. Oh, is it like, it's like twinkly. Yeah, I think that my hair does that as well. I think that I should probably wear brighter colored things. The dark color is a bit of an issue. I could zip this up. I don't know that anybody. Here we go. Okay, there we go. How's that? Better? How do I look? Okay, so, all right, so I'm looking at my list here. I will start by possibly pulling a few questions from the chat. So if anyone in the live YouTube chat or in the Slack chat wants to ask a question, put those questions in now. I'm going to open up a website for a second. And then I'm also going to look for, okay. All right, let me take a couple questions. How long have you been coding, asks Daniel in the YouTube chat. And Pyromania asks, do you like salad? And I really do like salad. I really love salad. I have a little bit of an issue with vinegar. It irritates my throat. So I've been doing creative salad dressings without vinegar. Thank you to Dr. Aviv for many great suggestions. But I do love salad. Oh, wait, is this what you tuned in to listen to? Probably not. How long have I been coding? That's a good question. I did do some coding when I was in middle school, just a little bit, using the basic programming language. I think I did some logo programming, possibly even some assembly language. And then I really didn't code actually until I was about 27, somewhere around there in 2001. I might have the age wrong, but so I would say about 15 years right now. I know salad dressing without vinegar. I'll get back to it. Okay. What's the best language for Android? Will you talk about processing with Arduino? And why is the Rails Girl Summer of Code page open? And what is processing.py? I can't remember all those questions. I already forgot the first two. I know I should code something to do with snow. I was kind of thinking that. Maybe if there's some time, I will do that today. Okay, let me get to the processing.py, by the way. Let me answer that question for a second. Someone asks there was a couple questions about Android and Arduino. So first of all, I don't know a lot about Android programming. It's not something I have a ton of experience with. I will mention that if you go to android.processing.org, this is a project where you can, processing, which is one of the tools I use a lot in my videos, you can get mode for processing that allows you to make Android applications and deploy them right onto your Android device from processing itself. So that is something you could certainly look into, and there is reference and tutorials and some information here. So, and this is a project that always needs help and contributors. So if you are an Android developer and you want to help out with this project, jump right on in. Now, right up here, I can see I'm going to click to processing.py. And processing.py is a Python mode for processing. And so if you like the Python language and you like processing, or you are interested in by the way, mention this. Somebody want a project? Hey, internet, here's a project. I'm going to go to github.com/Schiffman/the nature of code-examples. So this, I don't have a, this is the GitHub repository for all the examples from my book, Nature of Code. I've been kind of loosely covering examples from it, and I have a whole set of video tutorials that go with it. There are ports. If we go to the README file here, there are ports to many other languages of all the examples. Open Framework, Cinder, JavaScript, there's an entire P5.js port, Ruby, other. It's not even on this. I don't know why it's not. Let me kind of look for Python. It's not. I got to add it to that README. So if somebody would like to pull request to add this to the README, let me move over here. I'm going to look for Python, the nature of code. Here it is. The nature of code examples-Python, and you can see that only the first 4 chapters have been ported. So Python mode is a mode in processing that allows you to use the processing IDE, use the entire processing API for drawing, use almost all processing libraries, but write all of your code in Python. And the magic of this is that it runs on something I believe called Jython, with a J, but like Python, but with a J. So that it kind of like cross-compiles or does something fancy to make your Python code run with a Java virtual machine. The downside to this is that a lot of people think, oh, wonderful, I want to do stuff with NumPy and scikit-learn and NLTK, all these wonderful Python frameworks and libraries for machine learning or math or natural language processing, and then combine that with processing in the drawing API. This, from what I understand, isn't currently possible because of this whole Jython layer. However, if I could just put a challenge out into the internet, This seems like it would be a wonderful thing to try to figure out, to allow processing.py to both run all of processing stuff in Python and yet somehow have access to all of these wonderful Python frameworks as well. So if you're interested in that as a project and want to help with it, I'm sure you could send me a tweet or take a look at how take a look at the Processing Foundation GitHub repositories and just jump right on in. Okay, Arduino, I did have Tiga Brain, who's a wonderful artist, came and did a guest tutorial with some physical computing devices. I hope to have more guests in the future do some more hardware-based tutorials. In fact, it's not going to be hardware-based, but I have a guest coming in today. It won't be live broadcast, but sometime next week I will have a new video tutorial. And I guess I won't say too much about it because I'm not 100% sure what the content is going to be, but that's exciting. I'm trying to do more with guests to show you a broad, diverse set of people coding beyond me doing this sort of like math, geometry, shape stuff. So, okay. So one thing I want to mention, if you're interested in getting involved in open source, in general, I want to mention two summer programs that I think are great. One is called Rails Girls Summer of Code, and I actually learned about this program just this year, although I think it's been around for a while. And if I were to go, if you wanted to apply to it, I would go to apply as a team and read the eligibility. That's important to read. Read all of this FAQ. But the reason why I also mention this is that I'm looking for on the website for the list of what do you need to apply? A project, teams, no, selection, no. Processing Foundation is participating in Rails Girls Summer of Code. So for somebody I'm sure, maybe somebody in Slack can poke around the website for a second and just like quickly put in the live channel a link to where I find all the actual projects. Because a team maybe roles. I don't know why I'm not finding this right now. I'm sure it's obvious, and I'm having like just a moment of like on the website. So this is a great program. Processing Foundation has also applied to a program called Google Summer of Code. This you do have to be a student to apply to, a current student. You can be a graduating student, I believe. Now, this won't be available. Student applications don't open until March 20th, 2017. Processing Foundation has applied to be a mentoring organization again this year. We have been accepted in previous years. We have not been accepted in previous years, so we'll see what happens this year. But whether or not processing is involved in this program, it's a great opportunity to get involved in open source with a variety of different projects that certainly will be accepted into this program. So if anybody has questions about getting involved, a summer internship, that type of thing, I would say you can send me a tweet at Schiffman, and I'd love to help point you towards programs like this. I am sure there are many other programs. If there's ones that I'm not thinking of that provide funding for students or developers to participate and help with open source projects, please let me know. Okay. Ooh, look at this. Peter writes, I'll be starting a Coding Rainbow Club at our school where we will watch your videos to embrace STEM in a short, joy-filled session at lunch in our library in Ottawa, Ontario, Canada. Guidance. That sounds wonderful. So if people are interested in starting clubs or meetups where you use some of the videos or other learning materials and do some stuff with creating coding and making art and expressing yourself, please let me know. I would love to help out, even if it's just giving you an enthusiastic thumbs up. If I could, do a live broadcast, timing it where you're meeting and that type of thing, I'm open to all interesting and fun suggestions. So anything I can do to help, please let me know. That sounds great to me. Okay, so okay, so I'm gonna take my eye off of the chat right now, and I'm going to go back to my list of things. And I'm not seeing anybody posting in Slack. Anybody in Slack? I'm seeing lots of messages in the YouTube chat, which are great. Great. Thank you for all your nice messages. Okay, so now what I'm going to do is, what else do I have? Oh, merchandise. How do I'm not prepared. This is me not preparing. Okay, I see you're all there. Mathieu, if I'm a dummy and I forgot to put the if I'm trying to think, if you could send me a link in the live channel to just like a directory maybe with a bunch of preview images, or a link to some sample of the Gumroad stuff we were working on, send that to me and I'll pull it up to just make a quick announcement about that, because I've been getting a lot of questions and people are interested in, you know, getting things that say Coding Train on them. I don't know that you should be, but if you are, I'm working on that. Okay, and then let me think what I'm going to do first. So, yes, always on the list is Chrome extensions. I don't think I'm going to get to it today. It says running gag. That's my running gag. Boom, boom. Now, there it is. Okay, hold on, everybody. I'm going to switch to the other screen for a second. Void, you don't see anything. I'm going to click on this link. Open up. And I can click back. Okay, here we are. So with Mathieu's help, I am working on, and oh, by the way, all of these logo materials were designed by Jason Hegland. He's a wonderful illustrator of all sorts of amazing things. Oops, let's see it. I spelled his name wrong, Hegland. Maybe this is it. Children's books and all sorts of great stuff. So I encourage you to check out Jason's work, especially if you're interested and you need an illustrator for a project. Oh, look at this. Here I am, the Coding Train, Monster Match. He's got a bunch of Kickstarter projects, some great kids shirts. Here we are. So, and been working on setting up using a company called Printful, which does print on demand. And Gumroad, which is an e-commerce platform, to create, let's just go to t-shirts, I guess, maybe. Some t-shirts with the logo stuff on them. What's this? T-shirts with, oh yeah, some other alternative t-shirt designs. And some mugs. Different mugs, potentially. Hoodies even, perhaps. So you can see there's a lot of possible things that I am working on. This will be, I don't know where I am now. These will be out soon. So if you're interested, stay tuned if you have ideas or feedback on how to make that most effective. As you recall, I did previous t-shirts with something called Cotton Bureau. They're a wonderful t-shirt company. They do these limited print runs. And what I'm hoping to do at some point is maybe also do some kind of like special edition design through Cotton Bureau, maybe as a fundraiser for a good cause. So maybe like a coding organization that reaches out to underserved communities to teach about coding. So I'd like also to do a fundraiser at some point with some of this merchandise. But right now the stuff on Printful is just stuff that you can order and buy, and that sort of thing. Okay, so stay tuned. It's not a fundraiser for a good cause yet, so I don't want to miss that to be misconstrued. Okay, but I am thinking about that. So if you have ideas, thoughts, feedback, let me know. Okay, back to my list, my agenda. This is done. This is done. And now I just need to pick something. Okay, I recently fixed my little randomizer app. Oh, no. Oops. Okay, so I have this. I could really use help with this. Schiffman.github.io randomizer. This is all on GitHub. It needs a lot of thoughtful design. There's a lot more features involved that I would like. So if you're interested in helping out, this is a project I definitely could use help with. And what I'm going to use it for is I'm going to grab some of these things. So here are some things that I might do. Earthquake Data Viz Challenge. Processing in Eclipse. What is prototype, inheritance, and polymorphism in JavaScript? I already have an inheritance and polymorphism video in Java and processing. Whoops! I meant not to open up that window. That's why I switched to the other. Oh well. I don't think I invaded anyone's privacy there for the brief second that the Slack channel was open. Okay. Butterfly wings. Butterfly wings. So, by the way, I got to show work from the community. That's a new segment. Hold on, but while I'm working on this. Chrome extensions, nah. Finish Islamic stars. There's some things I want to do about that. And ripple effect, 2D water. I think I'm going to skip the particle effect stuff for today. I need to show this work from the community. Okay, great. So I'm going to hit submit and go to spin. Now I have my, oh, the camera's off. Yeah, camera's off. So this is how I'm going to choose what to start with. Yes, chat, I see the camera is off. Okay, now, let's do, this is tragic because I really need, there's an Ethernet port in this room, and I cannot for the life of me get it turned on. This giant, massive university, but hopefully it's going to be turned on soon. As soon as it's on, I can create my own little internal Wi-Fi network in this room. Right now I'm using the actual NYU Wi-Fi, and then I will be able to have more devices and things all hooked up to this recording system. I also want to mention that later today I'm hoping to do a live stream from my phone. YouTube just unlocked for me, I think, live streaming from a mobile device. So what I would like to do is do a walkthrough of the recording studio and how it works. I might try to do that today just from my phone, so there might be a surprise live stream later today. And then what I wanted to say was I want my soundboard because, and internet helped me out here, I want to have segments. So I feel like I need some bumper music for like, it's a coding challenge and work from the community with maybe a better name. But one thing that I like to do is, on the live streams, is show work that is made by people who watched one of the videos and expanded on it, as well as just work by inspirational artists working in the field and that are related to things that I'm showing when I do a topic. So for example, the reason why I'm interested in this idea of butterfly wings is one of my favorite artists, Katie Rose Pipkin. If you're not familiar with her, this is her website. I'm going to go to bots, and I'm going to show all these wonderful bots, but one of my favorites is the moth generator. So this is a Twitter bot that generates a moth design. I'm not sure how often, but it looks like once every couple of weeks, 11th, January 17th. And if we look at this, we can see it gives it a name, it gives it, and then it generates this design. So I have no idea how she did this, but I was thinking about, how could we write an algorithm at least to generate wing patterns that are different? And so that went onto my list as a sort of maybe to use Perlin noise and symmetry as a coding challenge. So anyway, so this is a commitment I have to show, and so today's featured artist is Katie Rose Pipkin, one of my favorites. Please check out her work, follow her on Twitter, tell her how wonderful she is. I'm a big fan. Okay, and maybe we'll do that coding challenge if our magic wheel gets to it. And what happens if I do this? That kind of works, yeah. Okay, now let's go back then to my document, and I would like to show you guys some work that has been submitted by people in the community over the last week. So let me start actually, I did a coding challenge about rose patterns. If you don't recall, this Wikipedia page I followed and looked at some math, some trigonometry math to generate these kind of patterns. And I will briefly show two projects. Now, I need a better way of crediting people because on this list, I don't know who created what and whether they want me to use their name or not. So that's just going to be however it is today. So let me look at this project. This is a nice example, and I will include, when this video gets archived and published, I'll include the links to all these projects in the video's description. So this is a nice demonstration of a little JavaScript interface. I can pick a color. I can hit draw again, and you can see it is now drawing the pattern with the color. I can change the parameters of the system. I can say 2, and I can say 10, and then I can hit draw again, and we can see a different pattern that I get. I can just change this to 12, and hit draw again, and we can see another different pattern that we get. So this is a lovely example by, dub over this video's person's name, and shout out in the Slack if it's you, of taking that rose challenge and doing something more with it. Let's look at another one, which is, which one did I just click on? No, I must not have clicked on the CodePen one. Here's one on CodePen. Look at this. This is the rose pattern in 3D. Look at this. So this is wonderful. I wonder if this is using WebGL. Oh, this is using P5's WebGL. I'm amazed and inspired that this worked. Look at this beautiful example of, S. Tarak in the chat says, it's me. So the previous example was by S. Tarak. If you want me to credit you by a different name than your handle, that's great. So look at this. This is wonderful to see a visualization of that rose pattern in 3D. And you can see there are X, Y, and Z components and a bit of spherical geometry going on here, spherical coordinates. So last week on the coding challenge, I looked at how do you convert between Cartesian and polar coordinates, and the extension of polar coordinates from a 2D circle to a three-dimensional sphere is this idea of spherical coordinates. And I do have a tutorial. I believe if you search on YouTube for Schiffman spherical geometry, you'll find that. Wonderful. Okay, let's look at some more things. Let's go back to the top and let's look at a couple of these games. I think these are by the same person. I want to look at this maze one. I think this is Florian Pop. Let's see if mazemenmultiplayer.herokuapp.com comes up. Ooh, okay. Get to the end tile faster than the others. The maze is auto-generated each time you play. How to play. Move with left, down, right, up keys. Okay, enter your name. Daniel. Let's play. Ooh, okay. All right, let's see. Can I do this? No, wait. Oh, that's me, Daniel. I'm so slow at this. Yes, I'm on the leaderboard. So I don't know. I think if you guys log into this, we might see you. This is like a multiplayer game. Can anyone please try that? And I'll wait here for a second. Ah, yes. Built with Love by Florin Pop. I don't know why I said Florian Pop. Apologize for that. Wonderful. And Kay Weekman in the chat, did I say that right this time, suggests that a P5 WebGL update video would make sense. Yes. I'm going to keep, there we got some more people. Haha. Leaderboard. Oh, you guys are way faster than me. I'm terrible at this game. Maybe this will now get me millions of subscribers. You know, my kids love to watch people just play games on YouTube. I mean, I'm like an old person, I guess, that I'm like so surprised. But I'm intrigued and amazed by this, and I think, what am I doing with these coding tutorials? I should just play Mario all day. I'm very good at certain games, especially car racing games. Wow, look at everyone. Wow, we're really giving this some load testing to see how many people this can manage. Wonderful. Hushimism in the YouTube chat mentions 3.js. Yeah, so if you're really looking to do web stuff in 3D, 3.js is a wonderful library by Mr. Doob. Okay, hello all these people, Abhishek, Mike, Ethan. Okay, let's go back and go to, what else do we have to look at today? So I think these are a couple different games, multiplayer games by Florin Pop. There's another one called X-Ball. Wow, look at this. What do I do here? Oh, this is amazing. Which goal am I trying to get to? Hey, look at that. So one of the things, by the way, I wanted to mention is that this is really terrific. Wow, this is great to see. Gabriel in the chat asked, have you ever thought about a P5JS or processing competition? I would like to stay away from the word competition if possible. I know I'm kind of like a ridiculous person in this sense, but I would love to think about collaborations and community-based projects, working together, but I'm a little less interested in things that are competitions, although I could imagine something that has the qualities of a competition where everybody makes something, submits something, and we get to share all that stuff with the community. Look how many, this is amazing. Boy, I feel like I have all this power on the internet now to unleash, to test people's network-based applications. This is pretty awesome. This is really making my day here. I feel like I need like Keystone Cops music. Okay, so a lot of people named Matt playing this game for some reason. Okay, so in the YouTube chat, people are asking, how do you submit community work? I need to figure out how to do this better. I'm kind of prioritizing people who are helping to fund my channel through the patron group, patreon.com/codingtrain, I think, or the Coding Train, I can't remember. But you can also tweet me at Schiffman. And actually, I would like to I'm not logged into my Twitter here. Let's see, I probably retweeted some things. So this is another way that's a promote. I'm not logged into, I'm logged into the Coding Trains account. So this is another way that if I can show things. This is somebody who made the math rows in 3D using Houdini. These are some examples of people using the Attractor coding challenge. This is a wonderful one by Cavehex on Twitter. You know, I really struggled in the Attractor coding challenge to make anything that had a kind of nice aesthetic quality. I was just kind of working out the algorithm, and I love seeing all these submissions of people who are really thinking about symmetry and color and design. It's wonderful, and you can see this is my terrible looking one. So I try to retweet stuff if it's an interesting take. This is wonderful too. This was not done for my videos. This was probably done previously, but this is some 3D printing with a lot of these polar forms. So that's another way you can share stuff with me. There were a couple good ones this morning that I probably didn't. Okay, so I don't know what this is. Let's look at this. Something biochemistry related. Look at this. So the other thing that I would say, especially if you're submitting stuff through the Google Doc, to write a 1 or 2 sentence explanation about what it is. I'm thrilled to show this. I don't have a background in biochemistry, but you can see there's something very biochemical going on here, and there's some options here. Ooh, I like the bonds look. This is a little bit small. I would love to see the layout of this page, maybe with this a bit bigger. It might just be what's going on. Oh, and this is look at this. This is actually in 3D. That is really cool. So this is a wonderful example that I will by so-and-so. And I guess there are different types of structures. Ibuprofen, which maybe if you're watching this video, you really need to take some ibuprofen right now if you're listening to me. Okay, and then down here we've got a force-directed layout by Kay Weekman, an interactive visualization of a social network of dolphins. This is awesome. I didn't even click on it, and I know it is. So this is great. So, and you can see, so what is a force-directed layout? A force-directed layout, or a force-directed graph is another term, is a way of organizing a set of data in a physical space, and having the qualities of the data, the numbers of the data, mapped to forces. So I looked at attraction and repulsion. So what if you're visualizing, this is maybe a bit of a trite example, but Facebook friendships. So a network of people and their social relationships. So the closer they live together, or the more they're friends, or the more that they like each other's whatever, photos, the stronger a spring force is between them, and then you just put all that stuff onto the screen and let it self-organize. And this is an example of that, and I guess there are some nice parameters here too, where you can kind of play with the actual physics of the system as well, which is nice to see. So this is great. You can use, I don't know if Kay Weekman is doing this, but you can use a library called ToxicLibs, which I have some examples and tutorials to do this kind of work. Wonderful. Thank you, everybody, for your submissions. I'm excited to show, I hit quit. Darn, wrong button. I'm excited to show that sort of stuff. Oh, come on, history, recent 14 tabs, restore all tabs. Okay, this is way too many tabs. Come back over here. Let me close tabs that are running JavaScript things. And did I get my, here we go. Okay. So it's 11:30, and I think it's time to do some actual, so Kay Weekman writes, I just used P5 and the springs are logarithmic. It is now time to do some coding. So there are a bunch of different options here, and I'm going to spin this wheel, and we're going to see what we get. I need a sound effect. I don't think I have one. We'll play the this dot song. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, whoops, this dot. Spin the wheel. This dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. No, don't be the water ripple. Oh, finish Islamic Stars. That's probably what I would have picked. Oh my God, there's a lot of movement on this arrow. I think it's stopped now. Okay, so great. Islamic Stars it is. How do I pause this music? Actually, let me get set up for this. I'll let the song play. was this,
This dot.
GitHub.com/coding
Never forget
train.
this dot. I'm gonna do the this dot, the this dot song. Never forget the this dot.
Okay.
Somebody composed that song for me.
Okay, so a couple things I want to say. Oh, okay. So if you might recall, I'm going to, oh, you know what? Do I have this on here? This is great. Okay, so a couple things I want to show. So first of all, I found a YouTube video, shockingly, of a talk by Craig Kaplan, who wrote the paper about computer-based design of Islamic geometric patterns. And that's the paper that I modeled the coding challenge that I did. And Craig Kaplan is also on Twitter. I can't remember what it is. Maybe it's like CS Kaplan, something like that. So if you're interested in diving deeper into this, this is an hour-and-a-half video, and it goes through in-depth history and thought behind the algorithms here. So that's something I wanted to mention. The other thing I want to mention is on Twitter, Gabriel Weymouth reached out to me and pointed out a major kind of flaw, not really a flaw. So let me come over here for a second. Is this camera is not on? Let me come over here and erase what I had from last week. I really got to wash this whiteboard. Okay, so the idea of the Islamic star pattern, the algorithm for it is, if you have a regular polygon, maybe it is a square, I don't know what you call this kind of polygon, rectangle, or let's say it's a hexagon, hexagon, hex for 6 sides. The idea is to create lines that emanate from the sides, pointed towards the interior of the polygon at some particular angle, and maybe separated by some delta, and then they meet. They meet at. I'm not doing this kind of in a terrible way. They meet at some point. So you can imagine if I'm doing that here, I might have something that looks like this. Boy, it's hard to draw. So one thing that I wasn't really being so thoughtful about, I was kind of doing a very elaborate algorithm because I was imagining that I could have a polygon that might have any kind of irregular shape, in which case it's still going to be the same. Yeah. So I was kind of imagining that there was a gross set of complex possibilities here of how these lines might intersect. So I was testing every side and every line and looking at line to line intersection and trying to find the right point. And Gabriel on Twitter pointed out, hey, you know what you could use for this? You could use something called the law of signs. So what I would like to do is do a quick coding challenge to update the tiling pattern with the law of signs. And it's going to make it much more efficient and easier to use for those of you who might like to make some projects out of it. I also would like to show, there actually have been quite a few variations on Twitter. I guess I won't, but the one thing that I wanted to mention, if I go back to this tweet, is Gabriel then also made a code pen where you can actually just look at this and how this works. So this is a nice simplified code pen that does this exact tiling pattern with hexagons. So since then, I have also received many wonderful pull requests on this particular GitHub repository, the star coding train / star patterns. And I also implemented the law of signs into it. And so I'm just going to show that to you very briefly. And you can see here, one thing that's now been expanded here is that I can change the tiling. So I can change it to a hexagonal tiling. I can change it to something called a dodecahex square tiling. And then I can also change the angles, change the delta, and you can see all the possibilities that are coming here. I think this might be some stray stuff that got in here. I'm not sure what this change cycle stuff, somebody submitted this and I didn't really look at it very carefully. And then what's wonderful about, somebody also submitted a pull request that allowed me to, let me just reset this or put these down back to 0. Put this back to 0. If I go and click this Save button. I can now actually download a JSON file. And if I open up that JSON file, it has a giant array of all the coordinates of all the vertices. So if you wanted to use that for some type of 3D printing or poster connected to a plotter, there's an update ready to install. You could do that sort of thing. So anyway, and I'm going to find somebody on Twitter actually made these beautiful prints. I should find this. I think it's Radio Dario. I think is Twitter name Radio Dario. Am I imagining that? Yep, this is right. So Radio Dario on Twitter made a bunch of posters with a plotter, and you can actually buy these. The shop and the proceeds of the prints are also going to some of the same charities that I mentioned in my video. So I purchased one of these. I can't wait for it to come. Maybe I'll hang it up on the wall right here. Okay, so all that aside, what I would like to do now is go back to my code and add and just adjust it with the law of sines to make it simpler, and then perhaps also add something like hexagonal tiling to it. Might be worth doing. Okay, so, and I would like to do that in about 20 minutes so that I still have another hour. I think I have till 1 o'clock to do some of these other coding challenges. Okay, I see some images being posted in the chat. I'm going to just take a look at this. Okay, great. Okay, let's see here. What am I looking for? Okay, so I need to find the original code. So let me open up Terminal, and let me go to Desktop, Star Patterns, Python, simple HTTP server, and let's see, GitHub, no, live. Yeah, so this is what I did in the last challenge. This is where I left it. So I'm going to kind of do a part 2 to that challenge with the law of sines. Okay, so now what I also need to do is Desktop, Star Patterns, live. I want to open up this code in the Atom editor. And yeah, okay. So, and then I also want to close this, and keep this over here, and over here, and there we go. And also, what else do I need? Coding train dot GitHub. Here, this. Okay, great. Okay, here we go. Yes, the Atom editor does have an HTML viewer, and there's even a package you can get to run a auto-reloading live server. I just weirdly prefer to run my own server for no reason. Okay, so here we're going to go today and start this coding challenge. Okay, let me come over here. 2, 1, 2, 1. I got to memorize these numbers. 2. So let's also open up law of sines. And let's just go to the Wikipedia page for that. Oh no, that's Hyperfoo. I like this page. Law of sines, Wikipedia. Oh, I'm in the wrong camera. Sorry about that. Okay, let's see if I can do this. And Jiku asked, did I miss something? No, I haven't really gotten started with any content. I mean, I've been talking and showing things, and it's 11:45. So here we go. I'm going to press some buttons on these cameras. And I'm going to do now a coding, I don't know, I guess this is a coding challenge in the sense that this is an update to the star patterns tutorial. Okay? Write something which detects which camera's on you. Yeah, I have thought about that. Okay. Here we go. Now, in case for some reason this is your first time tuning in, I do this very weird thing where what I'm actually broadcasting is my recording session. So I'm going to do a bunch of these challenges, and then afterwards they'll get edited into shorter videos and uploaded later as separate videos in different playlists. So I do have a lot of redundant content on the channel, but it does seem to be helpful. Some people prefer to watch the shorter edited videos. Some people like to watch the longer live streams. Some people watch a shorter edited video and then realize, I want to go back and watch the longer live version of it. So all of that is possible. I'm just trying to sort of put content out there. Okay, here we go. Let me start by having this. Let me close this because I just don't want to keep extra things open. I need this. I'm going to close this. I need this, this. Okay. Okay. So how can I make this look as nice as possible? Let's pick a good initial setting. I don't know what I'm doing here. Okay, that looks pretty good. Okay, here we go. Hello and welcome to a follow-up video on the Islamic star patterns coding challenge that I did. So this is, I don't know if this is really technically a coding challenge or what, but I had so many wonderful suggestions and ideas that came out of that coding challenge that I thought it would be worth doing a follow-up video just to add some features to it as well as correct, I don't know if error is the right word, but certainly a major sort of flaw in the way that I built that particular example. So this, by the way, is the current state of the community created version. People have submitted pull requests where now there are sort of nicer sliders for controlling the delta and the angle. There is, I can turn on and off the grid. I can try different types of tiling patterns. So I encourage you to check this out and contribute to it. The link to this, the GitHub repository for this particular version of it is in this video's description. Now, where I left it off, if you were watching just the actual coding challenge, was with this. And so just to remind you, the way to one technique as pioneered by a paper that I'll also link to by Craig Kaplan to create these star patterns is to have a regular polygon, like a square or maybe a hexagon, and to, from the sides of that polygon, send out rays at a particular angle. No, I'm not able to do this very well. and connect them. And so if, so, and you can imagine here on a, boy, I really shouldn't try to draw this. Time out. I'm gonna do that over. I shouldn't do things over. I should not be allowed. Okay, I need a, okay. I only get a certain number of do-over credits per live stream, and that should really be 0. That's 1. Are you keeping track of this? That's 1. I'm not going above 5 today. I think what I'm going to do, it's fine. I'm going to just do that again, because I don't want to waste all this time drawing in the video. Okay, here we go. It's a quad. Thank you. Thank you. Thank you, chat. Okay, so the way that the paper describes how to do this algorithm is to take a polygon, a quad, a hexagon, and to emanate rays. These are called, it's sort of a technique called the Hankin technique, which I talked a lot about in the previous video. Strange word to say, but it works. To send out rays from the side, and then send out rays from this side, and then connect them. So where they connect, and you'll see if you do this from all the sides and you tile the polygons in all interesting different ways, you'll get these beautiful star-like patterns, and they're wonderful. I enjoy them. They're nice tiling patterns. So what I did, I over-engineered it, I believe, in that I made this like polygon object and this edge object and then this Hankin object, and then I said for every edge, send the ray out and check every other edges in the ray and then figure out where they're all intersecting, then find the one that's the closest. It's kind of interesting. There's a lot of like useful math in there and good thinking. But really with these types of regular symmetrical polygons, those rays are always going to meet along a very specific, along the sort of the I don't know what to call this, the bisector of, they're going to meet at a very precise location that we can calculate pretty easily with something called the law of sines. So this was suggested by Gabriel on Twitter, who sent me a tweet saying, hey, you know what you could do? You could use the law of sines to calculate the length of the Hankin, just because you know the angle and you know the length of the edge of the polygon, and with some math, you'll be able to calculate that length. So that's the first thing I want to do is really simplify the code to use this law of sines. So let's look at what is the law of sines. This is the law of sines. Now, we could derive this from taking a triangle and dividing it into right triangles, but the simplest way to sort of define it is I'm gonna come over here, I'm gonna press this button, I'm gonna come over here, I got this. I'm gonna draw a triangle, and the triangle is going to have three sides, A, B, and C, and it also has three angles. We can call this angle maybe alpha, this angle we'll call beta, and this angle I'm just gonna call theta, I don't know. Got the C off, my Greek letters aren't the best. So the law of sines states that A divided by sine of alpha equals, so look at the side that's adjacent, that's opposite the angle. And by A, I mean the length of this. The length of this equals B divided by sine of beta equals C divided by sine of theta. So this is a formula, and we could figure this out because if we put a right triangle here, we're going to see that we're going to be able to do things like sine of beta equals this length over A, sine of alpha equals this length over B, and if we do some math, we're going to end up with this equation. So this is quite a useful equation in a lot of geometry scenarios. Now, why is it relevant in this particular scenario? Okay. Let's go back to that polygon. Let's say we have, and I'm really just going to recreate the diagram that Gabriel so nicely sent to me. So let's say we have this polygon. And let's say we have a ray emanating from here. I'm also going to draw a line that splits this particular angle in half. So now I'm going to send that Hankin out. This is the Hankin. It goes out like this. And the other one goes out like this, right? So these angles are equal. I'm going to call these angles theta. These angles are the angles in my application that I'm setting with that slider that's changing the direction. They're always going to meet right here. As they turn in, turn out, they're going to meet somewhere along this path. So we know this angle, theta, boy, can you see this? to zoom in on this. And now this angle I'm going to call alpha. We know that angle because we know the angle, the interior angle of a polygon. And actually, there's a formula, I think this is right. For any polygon of n sides, the interior angle equals n minus 2 times pi. Is that right? Because it's got 4 sides. Or divided by pi? No. Wait, time out. Shoot, I was going to look so good like I had this memorized. Does this make sense? The interior, oh no, divided by the number of sides, right? Yeah, sorry, hold on. I don't know if this should get edited or not. You can just leave it like this, but, and I don't want to use one of my credits. N minus 2 times pi divided by the number of sides. I think this is right. Let's just work this out for a quad. Right? 4 minus 2, 2 pi divided by n divided by 4 is pi divided by 4. Pi divided by 2 is 90 degrees times, all right, shoot, I have to look this up. 2 pi, hold on, I'm coming over here. Interior angle polygon. So the sum of the interior, oh, was I doing the sum of the interior angles? Should be, maybe I was doing the sum of the interior angles. People are saying it looks right. N minus 1. No, n minus 2 times 180 degrees. That's the sum of them. So then I have to divide, yeah, that's the sum. And then we have to divide that by, oh, I totally did it right. I just got confused. Oh, shoot. I had it right all along. I panicked. I'm using a credit. Edit. That's like how many times I'm requiring editing on the video? Twice, but possibly 3 times. Okay. The number of sides minus 2 times pi divided by, and that's the interior angle, because this is the sum. So if you think about this, this is equal to, with a quad, this is equal to 2 pi divided by 4, which is then pi divided by 2, which is right, that's a 90-degree angle. Okay, so that's leading me to the, we know alpha, because alpha is the interior angle of the polygon, and also divided by 2. So what do I really need to know? What I want to know is the length of the Henkin, because I know the direction of the Henkin, because I'm calculating that myself, I'm making it up. It's a line with an angle. So I need to know the length of it. So what I do know is, right, that length, Henkin length, I'm going to call it h length, divided by sine of alpha equals what? Well, here's something else known, right? I know this length. This is that mid length, half length. This is the edge length. So I'm going to say that's the edge length divided by 2 equals edge length divided by 2 divided by, what's this? Let's call this angle beta, sine of beta. But how do I know that angle? I don't know that angle. I know theta because that's an angle I made up. I know alpha because that's half of the interior angle of the polygon. But what's this angle? Well, actually, that angle is really easy to figure out because alpha plus beta, theta plus beta plus alpha equals pi, right? The sum of all the angles of any triangle equals 180 degrees, or pi. So now I can actually just change this to sine of, right? What am I trying to figure out? Beta? Beta equals pi minus theta minus alpha. Pi minus theta minus alpha. And then what I can just do is multiply both sides of this equation by sine of alpha, and I can say now times sine of alpha. So this is now a formula to calculate that Henkin length. The Henkin length, I need a Henkin, I got a Henkin for a Henkin length. The Henkin length is the edge length divided by 2 times sine of alpha divided by sine of pi minus theta minus alpha, okay? So let's see now if we can actually just radically simplify the code by implementing this particular formula and seeing if we get it right. Okay, coming back over here. So let's go to the code. Now again, this is, I think, quite over-engineered in the sense that I have a separate object for each edge, a separate object for each Henkin, a separate object for each polygon. That's maybe a little bit much for this, especially now that the format's gonna get simple. But I give that as a challenge. If anybody wants to help submit something to like really simplify this, you know, I don't know that we need all these different objects, but I'm gonna use them. And the first thing I'm gonna do is go into the edge. And if you recall, the code in this.Henkin does all this work to first find, the first thing that's fine is the midpoint. Then we need a vector that points from the midpoint to the edge. And then what we're doing is using delta to offset those things. So this is all the same. The difference is, and then we rotate by the angle. So now the question is here, it's this is what's totally unnecessary. This find ends function. This find ends function was checking everything. Because I can actually now, I can just do law of sines right here. This is all I need. All I need is once I've got those vectors normalized and pointed in the right direction, I just need to give them a length, right? Right here in this part is where I am here. So I've calculated both of these vectors, and I just need to figure out what their length should be. So I can actually do that math right there, which eliminates the need for this whole find ends function. And also maybe in the polygon object, right? This whole like every edge, check every other edge, totally unnecessary. We can just actually tell them all, calculate your own Henkin and use that, calculate your own Henkin and use the law of sines. So let's go here and let's use that law of sines. So what did I say? I'm going to look back over at that formula for a second. I said that the Henkin length equals, now let's make some things a little bit simpler. So let's say var beta, right? I need beta is, what did I say? It's pi minus theta minus alpha. So pi minus angle was theta minus alpha. Now we don't have alpha. What is alpha? So right now I'm just going to say alpha equals pi divided by 2, and this is a silly way to write it, divided by 2. But really I'm going to need, later I'm going to need some formula. I'm going to calculate, actually, you know what, let's just assume, let's do it this way. Alpha equals, so the interior angle equals sides minus 2 times pi divided by sides. This is me calculating the interior angle for a polygon. Now, then also I want to say then alpha equals the interior angle divided by 2 or multiplied by 0.5. So beta equals pi minus the angle minus alpha. That's that. So now h length equals the edge length. Now what is the edge length? The edge length is what? Well, this is a vector up here. This is a vector that points from the middle to the edge. So the length of these two vectors, right, is actually just the magnitude of that. So I can get the edge length right here, edge length, but also plus delta, right? Remember that delta is the thing that offsets it from the middle point. So the edge length is actually the length from the middle to the edge plus that delta. So that I have up here. So I already have E length. So I can say the Henkin length equals E length. And you know what I said in here? This was a sort of generic formula, which was E length divided by 2, but I already have that built in because the vector I calculated is this thing plus the delta. So in my formula, I don't need this divided by 2 here if this is length divided by 2 there. Okay, so what I have is edge length times sine of alpha and then divided by sine of the angle. What's the chance? And then I can just say v1 dot setmag, h length, right? Those two vectors are the Henkins. And v2 equals setmag. So all you need to do is set the magnitude of those vectors. Okay, now, I'm going to make that new Henkin object. So the Henkin object did all this elaborate stuff because it was trying to figure out the end, blah, 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 blah. I don't need this b anymore. This is the end. The end is the point from where it starts plus the vector, that Henkin vector. And I don't need this previous d, any of this stuff anymore. So I believe, and I don't need this find end function, which did all this elaborate math for looking at point intersection. I've got a much simpler scenario now. So that's why this Henkin object is perhaps not so necessary, because I've got this very basic object now that just has a beginning and an end point. And I could really call this, I might call this b, to be honest with you, just to simplify things. Okay, let's go back and run the code. Looks the same to me. So nothing has changed. But you can't really tell, but if this were like a much larger polygon or pattern, I think that performance-wise it should be a little bit faster. It's also simpler, it's more flexible. So this is working. We added the law of sines to the star pattern. Time out for a second. Oh, now I'm on 3, oh boy. Can I pay for them? How much is it per edit? Okay. All right. So now let's see. How is that so far and how long? So I think what I want to also do now, I'm looking at the time, it's 12:05, is maybe add a different tiling just to like see something more interesting, like the hexagonal tiling. Hexagonal tiling shouldn't be too hard, right? All I need to do is compute the vertices of a hexagon and then offset each row. Oh boy, it's going to be harder than I think, I bet. So, should I do that? I'm not so sure. I kind of want to move on to something else. You know what? I'm going to, that would be, I think other tiling patterns is its own video. So I'm going to actually just leave this one at this. Everyone's saying do it. Oh, that's great. Thank you, Robin Lefebvre. See, you said I wasn't going to pronounce your name because I'd be afraid of it, but I'm not afraid of it. I think what I'm going to do, because I can add other tiling patterns to my list of possible things, but I'm actually going to leave it at that. So, okay, so I'm going to wrap this video up. So this video, this concludes the discussion of how to improve and make much simpler calculating all the Hankin vertices with the law of sines. And hopefully you also just sort of learned something about geometry and that you might apply to your own scenario that you're figuring out in some pattern. Now, what would be useful is to also, as another step, to work out different tiling patterns. And again, I can show you a bunch here. Here's a hexagonal tiling pattern, and if I make the delta much smaller and the angle like this, you can see, right? You can see this is a hexagonal tiling pattern, and you can see how those Hankin vertices connect and make these star patterns. So I encourage you to experiment, to contribute to this repository. There's a nice way in this repository that you can just add a tiling pattern. If you take a look at it, you just make your own JavaScript file that implements the tiling pattern and it folds right into the, so I encourage you to contribute to this. And I will, if there's enough interest, come back and do another video which just goes through other tiling patterns. And I really actually want to do something about aperiodic tiling patterns at some point. So I'll come back. So thanks for watching this small addendum correction with the law, about the law of sines and Hankin star patterns. Okay. Master Mike, you're in middle school. Are you watching this while you're at school? Or maybe you're in somewhere in a different time zone where school is not happening right now. Okay. All right. So that was, I did something today. That's good. I'm going to close all this stuff, and I will update it. Oh, the B is not pronounced. Lefebvre. Lefebvre? Like Brett Lefebvre, maybe? I don't know. Anyway, okay, so let's go back to my spinning wheel. Did anybody see it here? Recently visited, recently closed. Oh, seriously, it's just gone. Show full history. This is dangerous. Dangerous. Where's the randomizer? Anybody see it? Randomizer. Here it is. Okay. I got it, thank you. Okay. B, development rates. I'm in 7th grade and I didn't really understand the law of sines bit. Wow, it's amazing to me the wide variety of people who are watching this, and I'm thrilled. I hope you're, not cutting class or something to watch this, although I guess this is learning, maybe. Does this count as learning? I don't know. But I realized that the whole law of sines thing would certainly be confusing, especially without a kind of background or basic understanding of trigonometry. And so what I might point you towards, I'm just going to look for, is trigonometry. There's probably better resources to this, like Khan Academy videos, but Polar, Cartesian, Schiffman, YouTube. I do have a set of videos. They're in the Nature of Code playlist, the number 3, which go over, actually, let me just go to that. that would give you some more background in this sort of thing. If you want to watch me talk about this stuff, that is. And so if I go into 3, oscillation, trigonometry and polar coordinates. So this video, I would think would be kind of like the prerequisite into that sort of law of sines video. Okay, Nicola, it is kind of working, the chat, because I can read your message. Okay, now, what did I just do? I did the finish star patterns. I'm going to remove that. Oh, it doesn't. Why? Where's my button for removing it? There we go. It's just hidden here because I'm remove selected. Okay, now we're going to do something else. We're going to spin the wheel. Okay, what are we going to land on? Butterfly. Well, I'm kind of hoping for. Oh wait, wait! I screwed something up. Hold on. Redo. Do over. This is supposed to be removed. Remove. There we go. Okay, now we're going to do it again. I'm going to really spin it. Here we go. Go. Okay. I'm rooting against ripple effect. Actually, that would be a good one to do. Butterfly wings. Of course, I rooted against ripple effect. It's totally going to land on that. Oh, it's going to be earthquake. Oh, it's the earthquake. Actually, I think I was rooting. I was rooting for ripple effect. Oh, go back to ripple effect. Earthquake. This is going to be a tricky one. I actually want to do 2. It is 12:12. I have about 45 minutes. So, okay, Nicola, I got it. In the chat, I was confused by the chat message of what was working. So, do ripple, please. Earthquake. Look, I'm a very small cog in the machine of the universe of the world. And the colorful spinning wheel tells me what to do. And that's all I can do is follow it. But nothing on this list. Eventually, I'll get to everything on this list at some point. This is just what I sort of felt like I wanted to do today. So let's do the earthquake challenge. And so I got to do a little bit of prep for this. And so what music can I put on? Please help me with my music, everybody of the world. Let's do Perlin noise.
So this is random, this is noise. Perlin noise, that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I picked 9 a lot, apparently. But with Perlin noise, I might pick numbers like this.
There was a big earthquake
2, 3,
recently.
4,
That's February
4,
6th.
5, 6, 5, 4, 5, 6,
so earthquake
7,
data.
5, 6, 7, 5, 6, 7, 8, 9,
USGS
8, 7,
earthquake.
6. Boy, this is like Perlin noise performance art.
Data.
9, 2, 7, 6, 1, 9.
Okay, here we go.
9, 2, 1, 3. I think 9, 1, 2, 3, 4.
So there's a few different things that this is going to cover. And I'll come back to that later. So one thing I need is I want the data feed. So this is what I'm looking for now. I've looked at this before. Maybe web services is what I'm looking for. Earthquakes, data, real-time data feeds. Spreadsheet format I can use. I'm going to use the spreadsheet format. Yeah. So this is what the USGS offers is every 5 minutes, for the past hour, earthquakes of the past hour, earthquakes of the past day, earthquake of the past 7 days. So what I'm going to do is look at, let's use the past 7 days data, I think, or let's use the past 30 days as the data. And I'll do all earthquakes. Let me just look at this. So is this going to download that? It's downloading it. Okay. So I just want to see what this looks like. I'm going to open this up in. So let me get a folder going here. I'll start with the roses. I'm going to do this. I'm going to do one in processing and one in P5. Earthquake viz. Let me open this up in Atom. And close this. Oops, I opened the wrong thing. Let me open this up in Atom. See, this is terrible that I'm using this.
So this is random, this is noise, Perlin noise that is, in the core random
okay,
algorithm,
so,
the actual random algorithm itself, those numbers
the camera
aren't
went off.
related at
Camera.
all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6.
So there's
7,
a couple
5,
things
6,
I want to cover
7,
with this
5,
here.
6, 7, 8, 9, 8.
I gotta just get the soundboard set up as a separate device. Okay, so there's a couple things I got to do here. So there's a lot of pieces here. One is I need the data. So let's bring the data in to that folder. So now we can kind of have a view into the data, which is here. Time, latitude, longitude, depth, magnitude type, et cetera, et cetera, et cetera. Okay, so this is the data. The other thing that I need is Mapbox, static maps. Okay, static map. So what I might need to sign up for I don't actually need this, but I think this will make it more interesting to look at. So I think I need to sign up. So here's a quick extra tutorial on how to sign up for Mapbox. Coding Train. Daniel at, this is not an actual, I better give it an actual email. Coding Train, password, blah, blah, blah. Sign up. Should have done this in advance. Add design. Okay, so what I want to do is, design a beautiful map. I don't know. No, I got it. I don't want the tutorial. Got it. So what I want to do is look for static maps. Why is everything so small today? I want to look for static maps, which I have done before. Where do I find that? Styles, tile sets, data sets, classic. Hold on. So Mapbox, static maps. Maybe now that I've signed up, it'll take me right to the page. Create a static map. Here we go. Using Mapbox Studio or a template style. Let's try the Studio. Oop. Get started. Oh, I think I want a template style. Let me try template style. I don't want to design a style for myself. Create a static map using a template style. Introduction, come on. Static, there we go. Using template style. Static. Oh, I want it. No, static. There we go. There we go. Thank you very much. So this is how I do it. Give me an example. So I'm going to do this. And I need an access token. So all I need now is to get my access. So if you're not, I'm going to talk about what Mapbox is in a minute. But I need a access. Oh yeah, this is actually what I want. Because I'm going to just do a full world. I need an access token. So where do I get my access token? Here we go. Studio. Can I get an access token this way? Account. Anybody know? Oh, here it is. Default access token. Copy. And if I go up to here and put it in here, there we go. Okay, great. So this is working. This is a link. Okay, so now I've got, and you know, I really do want to change the style of this, but I don't know that I have time to do that. So we're going to leave it just like this. That's one of the reasons why Mapbox is great, is you can design your own style. Okay, so I have the data, and now I have, let me just save this I'm going to just in case I lose this URL. I'm going to save it. And I also want to go to static maps here. And I'm going to just do here, going to come back to this page, static. Okay. Oh, look at this. I can change the style where right here, styles, map box, dark. I'm just curious, dark V9. Let's try that. Styles, map box. If I do this, change this to dark V9. There we go. Okay, excellent. So that's great. So I can use different styles right up here in there. Okay, great. I'm going to mention that as well. Okay, so now the other thing I need is something called Web Mercator. So these are all the pieces. Web Mercator. And I hope there's a formula here for it. Yes, here it is. Oh, wait. Is this really it? I thought it was simpler than this. One of these is longitude and one of these is latitude. We're going to be able to figure this out. Okay, this should work. Okay. Okay, so and now I need map projections. Whew, there's a lot involved here. So this tutorial is going to involve map projections, Web Mercator math, Mapbox.js, and how to parse a spreadsheet and draw to the screen, okay? So now I don't need this anymore. Let me just bookmark this for a second. Spin. And this might be the last thing I get to today. And let me just go localhost. Oh, I'm still in the wrong. Let me go back to terminal. Come on. See, is there an earthquake? Yep. Run the server. Hit refresh. So, great. All right. So now I'm going to close this. Did I bookmark it? Yeah. Okay. So I've got. So this I absolutely want to record an intro to it after. I think I might need a like a quick pee break, by the way. How long have I been doing this? Only an hour and a half. Usually I go 3 hours without, but maybe it was all this ginger tea I've been drinking. So I'm going to give you guys a quick. I'm going to take my microphone. Oh, I got to make sure I have my NYU key card, which will get me back into this room. I'm going to mute my microphone. I'm going to put on the This Dot song, which generally is people's favorites. And I will be back. How long is that song? Oops.
Perlin Noise performance art.
The song is...
As always, I always forget the this dot.
1 minute long. Okay, here we go. I'll be back 1 minute.
This dot. I'm going to do this dot. This dot. This dot. I'm going to do this dot. This dot. I'm going to do dot. This dot. This dot. This dot. This dot song. This dot. This dot. This dot. Never forget the this dot. This dot. This dot. This dot. This dot song. This dot. This dot. This dot. Never forget this dot. This dot. This dot. This dot. I'm gonna do this dot. This dot. I'm gonna do this dot. This dot. This dot. I'm gonna do this dot. This dot. I'm gonna do dot. This dot. This dot. This dot. I'm gonna do this dot. This dot. I'm gonna do this dot. This dot. This dot. I'm gonna do this dot. This dot. I'm gonna do this dot. This dot. This dot. This dot song. This dot. This dot. This dot. Never forget this dot. This dot, this dot, this dot, never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song, never forget the this dot. Somebody compose that song for me.
How did I do? I had to sing the entire happy birthday song twice while washing my hands, so it took a much longer amount of time than I expected. Okay, so I think I am ready for this now. And what I'm going to do is I'm going to record an intro to this afterwards because I would like to see what the end result is and have that up on the screen at the beginning of the video. Okay. You can't see my trains unless I make this much higher. Okay. In the chat, it's asked if it's snowing in New York City. No, we got about a foot of snow yesterday, though. I don't know how much it actually was. But okay, I'm going to start this coding challenge now. Hold on. Oh, no. That's for the intro. I don't need to do this ridiculousness. Never mind. I forgot that I just get to go right into it. Okay. Let me actually make sure all the cameras are kind of cycled. And let me erase all this. I don't know that I'm going to need the... There's some goofy stuff that's gonna, I bet you I'm gonna run into an issue with like radians and that sort of thing, but we'll see. I haven't done this, so I'm gonna run into a lot of issues, I'm sure. Let me just press a button on this camera. Okay. Okay, here we go. Let me see if I look. Do the laptops bother you guys? I need a slightly better solution. It would be nice to actually just have a really big screen up there and I could just do this. But anyway, then I'm always looking like this. Okay. All right, so I am ready now to start making this earthquake visualization. So there's a lot of pieces to this, and one of which, of course, is getting the actual earthquake data. But before I do that, what I want to do is just look at how I can display a map of the world as a flat image in Canvas. And I could do this in any number of applications, but I'm going to do it in the browser, JavaScript using P5 in the Canvas. So, and the API, the map API that I'm going to use is something called mapbox.js. So mapbox.js, you can go to mapbox.com, is a web service that has a lot of tools and mapping tools if you want to embed an interactive map into your application. I'm going to use a piece of it just called static maps. And what it allows me to do is it allows me to request an image of a map, and I can just load it as an image. Now, the Earth, you might be aware of this, is round. It's a sphere. I don't have anything spherical here to demonstrate it. But a screen, a window on the computer is flat. So if I'm looking at a map in a two-dimensional space, what I'm looking at generally is something called a projection. So if I go over here, if I go to this Wikipedia page, then this has been, there's a long tradition in history of different ways to take the surface of the Earth that's mapped around a sphere and pull it off and flatten it into two dimensions. So we can look here, I can sort of scan through this page and you can see here that there are a lot of different examples of kinds of projections. This is called the transverse Mercator projection. And you can kind of go down a big rabbit hole here and discover a long history of this. The kind of projection that I'm going to use is called Web Mercator. And the reason why I'm using it is not out of some like strong affinity or love for this projection, although I don't have a problem with this projection per se, is that it's somewhat of a standard. Now there is kind of a major issue with Mercator projection, which is that it grossly exaggerates the size of certain elements that are near the poles. And you can see this, like look at the size of Greenland as compared to the size here of Africa. I can assure you the continent of Africa is much larger than Greenland itself. So, so I think there are a lot of complex questions around what is a sort of appropriate and most accurate way of looking at a map in 2 dimensions? Where should the center be? I mean, the Earth is a sphere. How do you pick? Why is the center there? I mean, why is the, there's a lot going on with this question that I'm like talking too much about. But I'm just going to use Web Mercator as a standard. It is also because that's the Web Mercator projection is the image I'm going to get back from Mapbox. Okay. And so how does Mapbox work? Now, Mapbox, hold on, pause. I'm in the wrong place here. I meant to be under static map. Yeah, sorry. Is there a link to that? Oh yeah, because it's not giving me, sorry everybody. Why? There we go. I want to be on, there we go, static. There, that's what I want. Okay. And this should be fine. Okay. No, not classic. I mean, I could use classic. Oh, wait, all I have to do is hit refresh. No, all I have to do is type static up here. There we go. Okay. Sorry, everybody. Okay. Did I say anything problematic about map projections? I thought it's, it's very important, I think, to acknowledge the sort of like Western-centric view of mapping, at least that I'm kind of doing here, but I don't know what else to say about that. I'm sure people will have good comments and helpful comments. Okay. All right, here we go. Coming back. Okay. So coming back to Mapbox, one of Mapbox features is static maps. And the way that I can retrieve a static map is by forming a URL. And the URL has this format: v1 style /v1 /username style ID static longitude latitude zoom. So there's a lot to it, but the most important piece of this is I want to tell Mapbox what I want to get an image back, and I want to give it the latitude and longitude of the center of that image and then some level of zoom. So a high number is going to be zoomed way in and a low number is going to be zoomed way out. And we can see that here. I have one preloaded right here, and you can see the URL. Styles v1 Mapbox. This is the actual style, streets-v8 static, and I want the center to be 0, 0, and I want the zoom level to be 2. And then I want an image back that's 600 by 600. So if I hit refresh, I get this. If I change the zoom level to 4, it's zoomed in more. If I change the zoom level to 8, it's, well, I'm somewhere in the ocean, but if I change the zoom level to 1, we can see this. And now if I say what I want actually is 1200 by 800, then we can see now we're talking, look at Antarctica down here. It's all stretched out. So you can see, here we go, I've now got a map. The other thing I want to do with this is one of the reasons why I like Mapbox is that it allows you to custom style the image. And you can actually, using something called Mapbox Studio, completely generate your own style. But one of the ones that I happen to have memorized here, I think is called Dark V9, which I think will work. It's just sort of like a dark theme, which will work well because what I want to do is draw over it at points where there are earthquakes. Okay, so now that I have this URL, and by the way, you have to sign up. It's got an access token. You've got to go to mapbox.com, sign up for an account, find an access token, and I'll include links to where you can find all these pieces in this video's description. Okay, so I'm going to copy this, and I'm going to go to my P5JS code, and I'm going to say var map image, and I'm just going to use the preload. And I'm going to say map image equals load. So preload is a function in P5 that guarantees that anything you do in preload finishes before you get to setup and all the drawing stuff. So it's a quick way for me to, and I'm just going to paste that URL right in here, say load image that URL, and then what did I say, 1200 by 800? I am then going to create a canvas, and I'm just going to draw that image in the canvas at 0, 0. Okay, so now I'm going to go to my sketch, hit refresh, and there it is. So now I have in P5 a map loaded, and it's dynamic, right? I could change what I'm loading. You know, I could zoom in, I could have a different center, I could load different maps at different times, but I have that map right here, and I apologize for, you know, I guess what I want to do is maybe make it a little bit smaller, just for right now. So I'm going to make this 600 by 400, and change this to 600 by 400, so we can kind of see more of it. Yeah, there we go. And that'll do for right now. Okay, so all right, so now and I guess I can move this over here, and it'll just be above me a little bit. Okay, so there we go. Now that I've done that, step one. Now let's just for the sake of argument, to show that this is actually working, I'm going to draw an ellipse at 300, 200. That's 20, 20, and I'm going to say fill, you know, 255, 0, 0, 100. And I'm going to go over here and hit refresh. So you can see that I'm able to, that is the center point, 0, 0. I'm able to draw a circle there. So what I need to do next is pull in some data. That data will likely have latitude and longitude locations, and I need to figure out how do I translate from a latitude and longitude to a pixel XY space. And the answer is math, and the specific math is what is the projection that you're using. So what is the math behind taking this spherical map and unfolding it into 2 dimensions? And again, you can use different algorithms in different ways. Because I'm using Mapbox, the math that I need is Web Mercator. And so if I go back to this Wikipedia page, we can see these formulas right here. These are the formulas for Web Mercator. Now, there are 2 Greek letters here, lambda and phi. I think it's phi. And so which one is which? Lambda is longitude and phi is geodetic latitude in radians. So if I have, so let's just say for the sake of argument that my longitude and latitude is 0, 0. Let's put these formulas into our code, okay? So what I'm going to say now is I'm going to write a function, and I'm going to call this function Web Mercator X. And I'm going to give it a, X should have, right? What is, I just had to take a break for a second because I realized I always have to think this through a few times. Latitude and longitude, right? Let's go back to that Wikipedia page. And longitude. And we can see that longitude is east-west. Longitude are the lines that are long up and down. And those go from, they have a range of like negative 180 to positive 180 degrees because it's 360 degrees. Whereas latitude up and down is negative 90 to 90 because you only have, right, if you're going all the way around, then you just have 90 degrees each way. So I have to think this through. Longitude appear vertical, latitude appear horizontal, and the equator is the center. Okay, got it. And then longitude is lambda, and latitude is, I don't get any more, is phi. Okay, let's come back. That helped me. I just needed to like think that for a second, which I should probably just do in the video. Okay. All right. So I was looking at the formula, right? Okay. So x, right? If I'm doing x, lambda, and x is tied to, let's just think about this for a second, longitude. So if this is the Earth as a sphere, the vertical lines are called longitude, and those are going to tell me the sort of x location. And you can see how, as they get close to the top, they like appear in the sort of 2D view closer to each other. They come together to a point up here. So I'm not drawing this very well because they all come together to a point. So longitude or lambda, I need to convert into x. And the range, incidentally, right, a full rotation is 360 degrees or 2 pi. So it goes between negative pi and pi, I think, is typically how latitude is measured. And you'll see these as negative 180 to 180. I think this is right. Okay, so now, if I come back over here, I need to apply this formula. So I'm just going to do this. I'm going to do this as like 128 divided by pi. 128 divided by pi times power 2 to the zoom level, power 2 to the zoom level, and then times pi, lambda plus pi. So lambda is the longitude plus pi. Okay, so this should, if this gets a longitude and a zoom level, it should return this. So this is me. Calculating Webb Mercator X value. Okay. Now let's do Webb Mercator Y, and for that I'm going to be getting a latitude and a zoom level. Okay. So now, similar 128 divided by pi times 2 to the zoom. Oh, this now looks terrible. Okay, times what goes over here. So let me just break this formula up. A equals this part. B equals the second part. Pi minus log. Now, here's the thing. The ln is natural log, log base e. This is perhaps a topic for another video, logarithm function. But if you use the logarithm function log in a programming environment, it's doing the natural log by default. So this ln translates to logarithm. And I assume that even though these brackets are here, that's really just take the log of, I'm gonna say var c equals what goes inside there. Tangent of pi divided by 4 plus latitude divided by 2. And then, so the b is pi minus log of c. So now this is a, this is b, so I should be returning a times b. And if I were to just write Webb Mercator X kind of in the same way, sometimes I find this a useful thing to do to kind of break formulas into parts. It's a little easier to debug and read the code. So these should be two functions now to convert a location from longitude, latitude to x, y. Now, we got to do some exciting stuff here to see if we can get this to work. So what I'm going to do now is I'm going to just give myself a latitude and a longitude. And now I want to say var x equals Mercator, what did I call this? Webb Merc X, Webb Merc X longitude. Y is Webb Merc Y, Webb Merc X latitude. Now take this ellipse and draw it now at x, y. What's the chance that this is actually going to work and look right? It should just be right in that same spot, right in the center. Error. Sketch.js line number 9. I've got an error. Oh, I don't know what I'm doing here. This should be function. Boy, I had this syntax error the whole time, and this is a function. Okay, let's try this again. Where is it? Okay, so I think we've got something incorrect here. Let's try to debug this. Console.log x, oh, I think I have an idea. Ooh, no, that's not a good sign that I've got not a number. Okay, so first of all, I realize I'm going to have an error in a second, but that's fine. So I'm getting not a number. So why did I get that? Something is wrong in my formulas here. Let's take a look. Oh, I don't have the zoom level. Zoom, thank you. Somebody in the chat pointed this out. Of course, I need the zoom. Now, what was the zoom on my map? The zoom on my map is 1. So let's add in 1 as the zoom level. And let's make that a variable in the code. Var zoom equals 1. And I should really add that as a variable in here, but I'm just going to leave that for simplicity right now. I'm going to pass that in. And so zoom should be 1. Now let's do this again. Oh, there we go. That doesn't look exactly, it looks like something, but it doesn't look exactly right. Okay, I know what the problem is. I know what the problem is. The problem is I actually have incorrect value in that formula. So why does it say, let's try to figure this out. Why does it say 128 here? So this is assuming that the upper left corner is 0, 0, and the lower right corner is 256, 256. But this is not the case for the way that Mapbox. I believe that I actually need to use different values for Mapboxes using a different assumption there. So I think I remember doing this once before, and I think through trial and error, and I'm sure you could read about this in the Mapbox documentation, that if I change this to 56, whoops, where am I here? Okay, I'm in the wrong place now. Now why, okay. I know, okay, now there's another issue. My map is not actually, okay, so there's a major issue here. That's assuming the midpoint, now I know what the problem is. Okay, so I did everything wrong. So one thing that I need to assume here, you know what? Little edit thing. I know I'm on like number 6 edit here, but I think when this gets edited, we can go back to, let me go back to where this says 128, because there's another piece of this that I need to fix. Okay, so I'm going to go back to here. So what's wrong here? So one of the major issues here is that where is 0, 0 actually in my 2D coordinate system? It's in the top left. So, and how does Mapbox, where did that number in the code here, 128, come from? Well, the number 128 comes from, here we could say it's assuming that the upper left corner is 0, 0, and the lower right corner is 256, 256, which is not at all how my window is actually scaled. So the way that I want to do this actually is, it's going to make this work much better if I consider the center of the window to be 0, 0, not here. And then I draw the image around that center, and then anything is just offset from here based on that Web Mercator math. So if I come back over here, what I first need to do is I first need to say translate width divided by 2, height divided by 2. And then, now if I do that, what I'm going to get is the image offset because the corner is now in the center. But there's an easy way to fix that, which is that I can say image mode center. Now the image is back. Now what happened to this? Now here's the thing. If this is assuming that the top left is 0, 0 and the bottom left is 256, I could actually just say x is now going to be is the difference, 128, 128 is the center, right? So in other words, what the formula is giving me is this is 0, 0, this is 256, comma 256. So the center here is 128, 128. So when I get the value and I want to draw it from relative to the center, if I'm getting the value over here, like 200, comma 128, then I just need to draw it offset from that center. So the way I can do that is say x equals that value minus 128 minus 128. So let's see what I get here. Now it's over here. So why is it in the wrong place? I think actually, technically speaking, the values are doubled for the way that Mapbox works. Because I think it actually assumes 0, 0, 512, 512. And you can actually, you can read about that in the Mapbox documentation. Timeout. Let me think about this. Why did that? I should get 0, 0. What do I get? I get 256, 256. Hold on. Wait, hold on. We're going to figure this out. No, I'm doing something wrong here. What are the values? There we go. So why is that? Yeah, I could use the map function. I absolutely could use the map. Everyone's pointing out an easier way to do this. But for some reason, I'm like, my mind was going, I could just use my mind was going in a different direction. So it's 128, but I'm reading the chat now. Yeah. Yeah, I'm seeing lots of good feedback in the chat. So I could actually just do the width of the window, right? I could actually just do this, and that's going to give me the right X location. But I want to keep doing it the way I'm doing it just for right now. So let me go back to this. So why did I get this off? Because the top left 0, 0, I think, where is this? Lower right hand corner is 256. Huh. I don't know. But I'm going to fudge the math. I'm going to fudge the math. X must be, everyone's giving me good feedback, and I gotta keep moving because it's almost 1 o'clock and I want to actually finish this project. Okay, so this is gonna be complicated to edit, but I'm gonna go back to where I had it in the wrong place. So how do I fix this problem where it's in the wrong place? Actually, so the math, I believe for the way that Mapbox actually works, is the offset is actually, the numbers that I'm getting back are actually assuming that, that the center is actually 256, 256, and this is 512, 512, I think. Somebody in the comments I'm sure I'm gonna get a lot of comments correcting me, and I'm gonna have to come back and do like an addendum to this video. But if I subtract, oops, I'm in the wrong place. But if I subtract instead 256 and 256, now I've got my dot in the center where it should have been all along. Now let's really be sure this is working. So let me find a city in India. Okay, so let's look for New Delhi, latitude and longitude. So the latitude and longitude is 28.6139 north. So the latitude 26.6139 and 77.2090 east is the longitude. Oh, no. Wait a second. Yes, that's the longitude. Yes, because east-west is longitude. Now let's refresh this. I knew I did it wrong. I got non. Yes. I got to do this in radians, right? So those numbers are in degrees, what I'm going to find through a Google search or most things. So what I need to do is convert those to radians. And actually, you know what I'm going to do is I'm going to do that in the function here, because it probably in my code, so I'm going to say longitude equals radians longitude. And then I'm going to say here, latitude equals radians latitude. I'm going to convert those in the function. That's probably when I get to the earthquake data, it's going to come in. So now let me refresh. That doesn't look right. That doesn't look like the location of New Delhi. So there's a couple possibilities here. One is that, so hold on, I got to pause here for a second. I did this actually like a couple months ago. Yeah. I'm seeing some good, change 128 in X the formula to 300 and 120 in Y to 200. Map is not, 120 is not the X or Y of the center of your canvas. Yeah, I'm doing this totally wrong, which is that, yeah, don't translate to the center. Lots of people are giving me good feedback. Let's correct this. I actually, you know what, I'm just going to look up. I did this as an example. Where is it as an example? Where did I put it? Let me just see. Earthquake, Schiffman, Twitter. I did this like a while ago. I'm just going to look it up. Let's look at what I did. I did it on CodePen. So I'm going to, in the interest of time, I'm going to change view, editor view. Zoom, center, little center. Oh, I know what I have to do. What I do is that I find the xy of the center, which is 0, 0, and then I offset everything from that. Of course, of course, of course. That makes sense. That makes sense, right? And then I draw the circle at the difference between those two things. Yeah. I can't believe I forgot about this. Okay, this makes sense. Boy, where do I go back to now? So let me, okay, I guess, yeah. All right, there'll be bugs and things that I mistake in this. So, okay, so now I'm coming back in. Okay, I realize I've been thinking about this all wrong because what Web Mercator is giving me is, I got confused by the fact that 0, 0. So what I really want to do is, whatever the center of the map is, I want to find the xy, and then, oops. Let's do this again. I'm really running out of time here. Okay. I'm doing this wrong. Whatever the center is, I want to find, I need to look at the, because I might actually have a map that centers around a different longitude and latitude. So that pixel space is, I got to do this in a different way. So what I want to do is figure out what's the xy of the center. Then any point that I am doing, I just need to offset it by that exactly. So forget, this me trying to like hard code 256 or 512 is a bit of a problem. So what I actually want to do is have in var center latitude equals 0, var center longitude equals 0. Then what I want to do is calculate var center x equals Web Mercator x of the center latitude at a zoom level. Center y equals Web Mercator y center y at a zoom level. And then what I want to do is just offset it by whatever it's calculating. Okay, so this I think is going to work much better. And let me first, obviously this is going to work if I make this 0 and 0. Oops, why am I on this page? We can see I've got my dot in the center there. Now, let's try New Delhi again. And this I don't think is going to be right still. Okay, the same problem. But I think I know what the issue is now. I think I've got my zoom somewhat off. So let me pause for a second again. Let me look at my reference. Where was that? I closed it already. Let me look at the formulas that I used. Oh, this was going to be the easy one. Zoom, where's my formula? Yeah, 256. So yeah. I think tangent pi. We can look at this. Hopefully I got the math right. I think that Mapbox. Okay. Hold on, come back here. Okay. It's still wrong, and I said this before, but I keep being confused. I remember now that Mapbox actually uses 512. It doubles the pixels from that Wikipedia page. So what I actually want to do now is go back to my formula and change this to 256, and we should see, there we go. Does this look like where New Delhi is, people? Where's New Delhi? My knowledge of India, of the geography of India is not up to snuff, but I'm pretty sure that's pretty good. Let's look at New York, just to be really sure about this, because I do know where New York City is. Latitude, longitude. New York, 40. Here's latitude, longitude of New York. Now there's an issue here. So this is New Delhi. Comment that out. And now I'm going to do New York. Comment that in. And I'm going to put 40.7128 for the latitude and 74. Now here's the thing. Notice that this says west. What that means is west is over here, east is over here. East is positive, west is negative. So if I'm looking it up or if I'm getting a data source that's tagging things east or west, what I actually need to do is change this to negative. So let's do that. And now let's see. Let's refresh. There we go. That looks like New York City right there. That's where I am right now. Okay, so now we have got our mapping working. So, it took us a while just even to get to this point. Now's the time where we can actually start to use the data. So how do I get the data? So you might be doing some mapping application with any data source, but the data source that I'm going to use is from the USGS. This is scientific data about earthquakes. And this will give you, there's a bunch of different feeds for significant earthquakes, only earthquakes that are 4.5 plus. But what I'm going to actually look at is just all earthquakes from the past 30 days. And this, you notice, updates every 15 minutes. This updates every 5 minutes. So I could build an application that checks every so often. But what I'm going to do is I'm going to look for this link, and I'm actually just going to click on it, and I'm going to copy that link address. And what that link actually, what it actually gives you is this particular CSV file, and so which is a spreadsheet. So I'm going to open. I'm going to go to, the folder, and I'm just going to quickly preview it. It's a lot of data, actually. I should have probably started with something smaller. But you can see here that it's giving me a spreadsheet. The time, the latitude and longitude. Luckily, it's doing the positive and negative thing for me, so I don't have to worry about that. And then a lot of information about the actual earthquake itself. But the number that I might use is magnitude. So what I want to do is I'm going to use the load strings function. There is a load table function that you can also use to load a CSV file, comma separated values spreadsheet. And when I'm going to do a processing version of this that's in 3D, I'll use that load table function. But I think for simplicity right now, I'm going to just say data. And I'm going to say data equals load strings. And then I just need that URL. Do I still have that copy pasted in here? So I have that, and I'm just going to, in the beginning, say, just to see that data comes in, I'm going to say console.log data. And here we go. I'm now going to go back to my sketch, hit refresh, and it does look like that data is here. So we can see that data is here. It has a header row, and then it has rows with all of the stuff on it that we want. And you notice that what I want is this I think that's the, whoops. We can see here, it's the latitude, it's time, latitude, longitude. So what I can use is the split function. The split function in JavaScript allows me to split a string based on a delimiter. So if I have a particular string that's got something like, time, lat, longitude, I can just say, hey, split by the commas and give me an array with time, latitude, longitude. So what I can do here is come back to my code, and I can say, and I'm going to move down here, I can say for var I equals 0, I is data.length. Load strings gives me each line is a separate element already into an array. And then I can say var stuff equals data.split by comma. Now this looks a little bit strange. Why am I using these forward slashes? Why not just do this? Now this might actually work. Split by comma in single quotes, but JavaScript allows you to split by something called a regular expression, which is a pattern you're trying to match. And the pattern that I want to match here is very simple, just a comma, but there's a lot more you can do with that. I will refer you to all of my regular expression tutorials. Then I'm just going to say console.log stuff index 1, stuff index 2. So why do I say 1 and 2? Because the array is time, latitude, longitude. Time is index 0, latitude is index 1, so I want to look at 1 and 2 and just see if that kind of comes out. Data.split is not a function. Oh, right, data index I. So I can only split a string. Data is an array of strings, one on each line, and I want to split each one at a time. So now let's look at that, and you can see this is pretty good. I'm getting all, and there's a lot of data there. I probably should make a demonstration with much less data, but there it is. I did all earthquakes. Boy, this is really a lot of data. But let's just go for it. Now what I'm going to do is, look, just going to take this. This I can put on the top here. Then I'm going to just keep all this in here. And what I'm going to do is say that var latitude equals stuff index 1, var longitude equals stuff index 2. Now here's the thing. Those are coming in as strings. The data generally comes into text. I have a feeling I need to convert it to a number. I might not need to, but I'm just going to put it in there just to be safe right now. Then I am going to calculate the xy and draw, and I'm going to draw a smaller ellipse. And we should see now, sketch line 54, I think I lost an end curly bracket. We can see now that what I'm going to do is just draw circles. And you can see it's taking a while. And look at this. Does this make sense to you? This is where all the earthquakes would be. Now there's a lot of little tiny earthquakes everywhere. And what I want to do now is also just make, I want to get a much bigger map so I can see more of the world. 1200 by 800. And so let's make the canvas 1200 by 800. And let's refresh this. I should have used less data. Oh, I'm off. Something is off. First of all, let me make this so you can see it a bit better by saying no stroke. And let me make this a little bit brighter. Loading, loading, loading. So I'm off by a little bit, right? Because all of this should be clustered right around over here, and this should be clustered right here along Alaska. I definitely want to skip the first line, thank you, because the first line is the header. So I got to pause for a second, and what did I miss? Okay, let me go back to my example. I probably have, and what did size? I used 1000 by 600. Angle mode radians. Oh, there. No, that should be fine, because that's the default. Pi, longitude. Oh, no. Yeah, pi. I'm using longitude everywhere. Translate with minus. What's W and H? Oh, because I have it offset. That shouldn't matter. Merc x equals 2. Yep. Yep. Why? So let me just try, for the sake of argument, 1000. You see what I get here? Whoops. You can see the. Oops. I want to see. Let me get a full view. This one is correct, right? You can see all these spots look right. And by the way, there was, I guess, a very large earthquake over here. I think okay, I'm looking at the chat. We told you 100 times that the number 128 in the formula had to be halved width and height. You didn't change it yet. It's not 128 or 256. It's width divided by 2. Change 256 in the functions. Okay. You used long in two places where I should have used lat. N function, web Mercator Y, one line, missing semicolon. So there's a lot of good feedback. We told you 100 times that the number 128 in the formula has to be halved, width and height, and you didn't change it yet. I really got to look at the chat more often. Okay. So this, you're telling me, what you're telling me is that this should be width divided by 2? Or height divided by 2, maybe, actually. Whoops. Why? Oops. Wait. Come back. Var W equals 256. Let me just do this. And what you're telling me is this should be width divided by 2. Let's try this. No, so that's spread out way too much. Is it based off the height? Height for y. Yeah, but I don't think that's how it works. But let's see. I think that Mapbox, the thing is, I should do this with a square. Let's do this with a square, because Mapbox chooses, let's get this right. Let's do 600, 600. I should really use less data. Oh, look at that. This looks right. I think, right? Or maybe not. Question is, let's make this 1200 by 1200. Whoops. Yeah, that's not right. It's not a square. Var B is missing. The semicolon is not, the CY function is wrong, someone's telling me. Oh my goodness. Ugh. Whoa. CX should be this. Wow. That's a big mistake. That could have definitely done it. Yikes. Oh, so sad. C lat, C long, lat long. Didn't matter when it was 0, but it is still 0. Let's see. Just see here. Yeah, okay. So I think now I can go back to 256. I think that was my problem. 256. That's still off. What's wrong here? Don't have to change it in the URL. No. Oh, I do have to change it in the URL. Ah, thank you. Irk. Of course I do. So let me be more thoughtful about this. Let me actually just do it. Let me hard code it here. Totally, that's also going to be completely messing me up. Sorry. Okay. Now what you're telling me is, if I go and say width divided by 2, width divided by 2, oh, this is a big failure. It's already 1:15. How come, what did I do in my previous example where it worked just fine? Debugging, let me look at this again. Let me grab this code. Save as. CodePen.js. And let me just load something here. Let me just try something here for a second. Let me run that old code and see. I'm sure I have like a really... Okay, so this code looks right. That's my old code. They're saying width for one and height for the other. I know, but I made it a square. So if I make it a square, width and height are the same. Right? So what I want to look at is this code here. Forgetting about the size, earthquake split, number 2, number magnitude 2 and 1. Translate to the center. Merc X, Merc Y. Do I have just a mistake in... Let me grab these functions. Does P5 do angle mode degrees by default? I wonder if it does. I don't think so. I had in that code angle mode radians. Let me just make sure that's not the issue. I have 256 in my other example that works, which is why I was thinking that is right. Oh, I'm in the wrong sketch now. Too much data. Okay. Okay. I'm looking at the chat. It does radians. You need to use the degrees function. Where do I need to use the degrees function? Where I wouldn't be surprised if there is an error where I'm thinking of pi divided by 4.0, latitude divided by 2. I'm converting them. This all looks the same. Okay, hold on. So let me put these in here. These are simpler versions of those. Oh, that's right. Is there an order of operations thing here? I don't think so. But let's use the other formula. Same. And let's see here. Let me grab the image I'm grabbing here. Let me grab this. I wonder if, I think there's an issue. The web browser zoom, I don't think it should. Sorry, everybody. I might come back later today and finish this one, because I do have to leave very, very soon. I have a sort of weird feeling. I have a memory now that when you ask for an image like really big, you get some weird results maybe, but 001, is that what I used in CodePen is zoom, so I have all these as variables, 001, access token, yeah. I made my own style there. Okay. And then, so 1,600, and then 1,000, hold on. Stop centering the canvas and the image, remove the offsets everywhere, make sure the canvas size is the same as the static map size. Correct the formulas to have width divided by 2 and height divided by 2. That's probably a good idea. Thomas Leone in the chat mentions. That's probably a good idea. But I'm curious why I did it this way before and it worked. 1,600. And then 1,600. Let's go. Whoops. Oh, look at that. Now I have it correct. I think this looks much more right. So, but something is drastically wrong, I think, because let me do something here. Okay? So I'm going to add these variables. 1,600, and I'm going to load the image. Plus WW plus X plus HH plus this. Okay? So now I'm dynamically, and then I'm going to create the canvas with this. So I do have something wrong. I even have something wrong in my previous one. So this is now going to work. This looks right in that I've mapped everything, but I'm so sad about this. But watch what happens if I go to like 1,200, change that to 1,200. Yeah, it's not right anymore. So I did this wrong, and it's like it worked by accident because I found kind of like a sweet spot. So I think that everybody is right, and Lucas and this like centering of the canvas and everything is a completely incorrect technique of doing this. So the image of the canvas side, the thing that's weird about this is that the reason why I needed to do it around the center. Let me just explain this though, because I do agree that I've done this incorrectly. But I think the issue is that, so I definitely need to stop doing it from the center, but let's say I ask Mapbox for this particular map. I'm going to get, it's a good thing, I'm going to get like, whatever. I can't draw, but you get the idea. Now, if I ask Mapbox with the same center and the same zoom, but I say instead of, let's say this is 1,200 by 600. Let's say I ask for it 1,200 by 200. So I get this. It's not going to squish this whole thing into this. It's still going to be, Mapbox is still going to just give me this. It's going to give me just this slice. So maybe it's just assuming, maybe it's always giving me the image based on the width of a square. So if I say 1,200, 1,200, the mapping is actually this, which is why I wanted to do everything relative for the center, which still should work, but maybe I just need to consider this 0, 0, and this 1,200, 1,200. So it still should work exactly the same way if I then fix this. Let me go back to web. Right? And if I change this is why I thought if I change this to width divided by 2, and width divided by 2 here, and then everything is relative to the center, but everything is off too stretched out, unless this is correct because there's actually a lot of earthquakes out here in the Pacific Ocean. But I assume that this doesn't seem right to me. I don't think that height, right? Because here's the thing. This is what I'm saying. Like, look at this image, right? I'm asking for an image now from Mapbox. That's 1,000 by 600. But let's say I change this to 100. It's not going to squish that image within 100 pixels. It's just giving me the slice of the center. So the points should still be in the same place. What I think I want to go back to again is not using the data and just placing some known cities. So let's, and I'm going to have to come back today and finish this. I'm sorry, everybody, this is a total failure. So sad. So I'm going to take this out. Oh, I don't have those latitude and longitudes anymore. So let's try San Francisco. San Francisco, latitude, longitude, because that's something along the West Coast that we can really, so it's this. So what I want is this. And I want latitude to be this number. And longitude to be this number but negative. And I also just want to draw an ellipse at center x, center y to make sure that is making sense. And the camera's about to shut off, I'm aware. So let's see here. You need a function that changes the x and y in the ratio of your canvas with width and height. I think that's correct. I think this has to do with the aspect ratio and everything. Okay, so let's look at what I've got now. So I don't see anything. Oh, this should be center x minus center x. That's silly. That's obviously going to be 0, 0. Now, this is hard to see. Is that the center? I mean, of course it is. This camera went off. I might just need to read the Mapbox documentation more. By the way, incidentally, let's do something here where the center, I just want to see something. The center, let's make sure, is actually this. And the zoom level, whoops. And the zoom level, I really have to go. The zoom level is, let's make it like 4. And 600, 600. Let's just look at this for a second. Whoa, something is wrong. Oh, because, okay, hold on everybody. This also has to be, where do I set the center? Whoops. Plus center x plus comma plus center y plus comma plus zoom plus slash. Is that right? Is it longitude, latitude? It's probably latitude, longitude, right? It's probably what Mapbox is expecting. Oh, it's here. Sorry. C-lat, C-lat, C-long. And zoom is 4. Okay, let's just see what I get here. So, Oh, the camera's still off. Ah, sorry, guys. I hit the wrong switch. Sorry, I hit the wrong switch. I learned my lesson. I mean, I've learned my lesson so many times. Check the URL from CodePen. Okay, Mapbox, earthquakes. What is, let's look at the CodePen one. Longitude, latitude. I did it the wrong order. Longitude, latitude. Ooh, look at this. What did I get? Did I get New York? I must not have put San Francisco in, because that is very clearly New York City. That's weird. Oh, I did New York City. I totally did New York City. Let's try it. So it's working, but San Francisco. San Francisco, I just want to do San Francisco lat long. So what I want to do is this is okay, San Francisco. San Francisco. Okay. What's this here? Oh yeah, get rid of this. Whoops. So let's make this. Let's make this now. Let's make this. There, okay. So I want to draw San Francisco and I want to draw New York. So this is New York, the center. San Francisco is where the XY is. Now let's look at my map. Getting New York in the right place. Now let's look at, let's zoom out a bit. San Francisco is not appearing there. Let's do it the opposite. Just because I can. C-lat, whoops. C-lat, C-long. And this is now going to be this here. Lat, long. So I'm getting, Mapbox is working the way it should perform, but I'm not getting this in the right spot. Now what do I have, which function? I'm using this one with width divided by 2. Width and height is the same. And what you're telling me is if I try to just put 256 in here, this is using that function. Yeah, with 256 it works. Look at that, that's right. Interesting. Let's do all the earthquake stuff. We'll at least see the earthquakes around. Whoops. Oh, am I not loading the data? Did I comment that out? Yeah. Loading, loading, loading. Yeah, look at this. This looks very much like what the earthquake data should look like. I'm pretty sure I have this right. So why is it, if it's a square and it's 600 by 600, 1200 by 1200, zoom level 1, yeah, look, it's off now. Why? 1,000, 1,000. I think it doesn't want to give you an image bigger. No. 800, 800. Do I have something somewhere? That looks right. So as soon as I go bigger than 800, it seems off. You restrain the width and height to the Mapbox. Oh, there's a Mapbox ratio max. I think Mapbox has some kind of static Mapbox max ratio maximum. The maximum size for a static is 1280 by 1280. The absolute pixel size limit does not change when using the 2x suffix, making the max size for retina images 640 by 640. What's the chance it's giving me a retina image? And so I'm actually getting something off. Well, it worked. Yeah. Replace dot with dot. Okay, everybody, I'm going to come back today and finish this before the end of today. I'm going to look at this some more this afternoon. And I don't know where, I'm going to splice this eventually together to be a finished tutorial. Pixel density. Oh my God. Don't tell me it's all been pixel density all along. I don't think so, though. I don't think so. I'm pretty sure that this one is wrong too. And it just the values that I used, it happened to be right in my CodePad one. Yeah, I don't think the pixel density has been fine. And I don't know why this is fine at 800, 800, 900, 900. Somebody in the Slack chat has posted me something. Uploaded this image. Center point was off. It might have been. Yeah, this is wrong. As soon as I go to 900, 900, things are off. Let's change the center to 0, 0. And that's right, I think. Latitude, let's go to maps.google. Whoops. And look up 0 latitude, 0 longitude. Do that for me. How do I look up latitude 0, 0, lat, long, Google Maps? I'm really going off the deep end here. I know how to do this. I can just edit New York. There we go. 0, 0. One zoom. That didn't work. Okay, I give up. All right, everybody, just put in 0, 0. I know. Okay, thank you guys. This has been boy, this hasn't been my best work. So determined to, I get very stubborn and I don't want to leave. I have to check something if I'm actually right about this. That I have office hours appointments starting at 2 o'clock and I haven't eaten any lunch. Let me just see. I am coming back today. Whoops. I'm just looking up my calendar on this computer. Schiffman here. 2 p.m., yes. Okay. Okay, so thank you guys for tuning in. I am determined to solve this. I would be thrilled. I'm going to paste my code right now into a GitHub gist. If anybody has time today to read Mapbox documentation and look this over, earthquake.js, and look at this code. Whoops, stay. Whoops. I'm going to create, I'm not signed in. Can I just create an anonymous gist? That's probably a terrible idea. I will, can somebody copy this down? wait, I know where to, I'll go to the YouTube chat. Sorry, I bet you if I go to YouTube, Schiffman user live. Oh, user, sorry, yeah. User Schiffman live. Am I logged in as somebody? Create a chat. Oh, I'm not logged in as anybody. You've got to be kidding me. I can't even post something in my own chat. I guess I should log into GitHub. Okay, start. Let me log into GitHub. That's going to take me 2 seconds. Schiffman. Fine. I don't know. Sorry about that. And is this now in my account? Oh, look at that. So if you just go to gist.github.com/Schiffman, it should be right there. Mapbox-test.js should be the first one that you can find and look at. So if anybody has some time, I have appointments from 2 until like 4 or 5. I'm doing a guest video, then it's going to be into the evening, but I am not going home today without this solved. So I am going to, I'll tweet this link out, sure. I am going to be back for part 2 of today's coding train. I'm sorry that this is the first time that I've really gotten this stuck. And I'm not sure, but I wouldn't be surprised if it's something like really quite obvious. This is, by the way, I don't know about you, but this is how it is for me if I wasn't doing this as a live stream. I always run into issues like this. It's a little easier to solve, I think, when you're not live broadcasting on YouTube. I have no idea how many people are watching right now. I have a feeling I'm about to be down to less than 100 people at this point. But then I'm going to come back. I will either like redo the coding challenge again from scratch, just because, or once we get over this little hurdle, or I will just sort of pick it up from some point in the middle and our wonderful Mathieu will edit stuff together. So this, if you're watching this as an archive of this live stream, this will eventually be archived on YouTube. If you're actually still tuning in right now, I can't imagine that anybody is. Then look for the next video or just go find the actual edited coding challenge, which will hopefully have all of this solved and corrected and nice. And then people on the internet will make beautiful mapping visualizations. So there are over 600 people watching? No, that's insane. I feel like I have to let me do some like a dance or something to make this more entertaining and nice. I'm looking at the chat, Rosa, and people are like, no, this should make you feel good about yourself, because either the same thing happens to you and you realize that this happens to all programmers, or number 2, you don't have, is it the wrong code on GitHub? Or did I put the wrong code in here? Oh, it's the wrong code. Thank you, everybody. I mean, it's useful code because, whoa, that's totally the wrong code. That was something else that I put on GitHub 2 months ago. Thank you. I'm fixing that. New gist. Mapbox. Wait, earthquake. Yeah. I just got that. Thank you. Wrong code on GitHub. Now I'm putting it in. Here, can I put a bounty on this too? I'm getting ready to make t-shirts available. So first person, I don't want to give out 2, I'm happy to give out 5 t-shirts actually. I know, but what's one person? I guess it has to be the first. Okay, creating this gist. First person to send me corrected code plus an explanation. I might get to it first, but I'll still give out the t-shirt because I'm going to look at this. I will send a t-shirt no matter where you are in the world. I will get that t-shirt to you somehow. So if you want to take a look at this, you should now be under gist.github.com/Schiffman. You can get in touch with me. You can send me what you've done with @Schiffman on Twitter would be the best way. You can also probably pull request this gist somehow, but I think, let's say it has to be on Twitter, because then at least I can look at the timestamps. So you'll have to be a Twitter user to participate in this free t-shirt thing. Whatever, I don't know, maybe this is silly. I always worry now I'm doing like a contest. I don't like things to be competitive. We should all just help each other. I want to give as many free t-shirts out as I possibly can. But anyway, if you have a chance, take a look for that. If you live in Antarctica, I'm getting you that t-shirt. No matter where you are. I like that Y man asks, how did you become so good at maths? I don't know if I'm so good at maths, apparently, as we watched today. Look, if I can't get the t-shirt to you, I don't know. You guys are trolling me in the chat to try to think of places. I will hand deliver that t-shirt, although I'll do my best. Okay, you can also gift your t-shirt to somebody else in another part of the world where it'd be easier to ship to. Okay, so I will see you guys. I will come back live at some point today, even if it's just to say. But I got to run. So I'm gonna turn this off. I'm going to, I will come back to it later. So I'm gonna put on my little song here. What if you live at 0, 0? I'm gonna do some meditation. Ow. Yes, hopefully somebody on the International Space Station solves this, because that would be fun to have to go handle it right there. Although I have a feeling I would have like multiple anxiety attacks on the way to the space station, because that sounds very stressful. Okay, everybody. Thank you. Kittens. Oh yeah, I don't have Lost GH Bear. Let me get the kitten. Do I have the kitten song? I just don't have it. This is my like temporary soundboard thing, and I don't have your kitten song in it. I'm gonna correct that. I can't remember if it was on SoundCloud. It is Lost GH Bear. Here it is. Let's do it. Lost GH Bear. Lost GH Bear. Kittens. And where's the download button? More. Share. No. Don't understand the SoundCloud interface. But guess what? Say goodbye to the kittens. Yes, I am just having if I had lunch with me, I would just eat it and continue to work on this problem. But my lunch is downstairs. Siddharth Singh, if you can provide an explanation, yes, just providing an explanation is fine. You don't have to correct the code. See you guys. I'm sorry that this was such a complete and total failure, but in a way, life is about, what's the famous quote? Life is about moving from one failure to another with enthusiasm. Is this Churchill? Let's find this quote. Success is going from failure to failure without losing your enthusiasm. I'm pretty sure that's Winston Churchill. But who knows? This is another mystery. Unsolved mysteries. Coding Train, unsolved mysteries. Success is going from failure to failure with enthusiasm. And that's what I'm doing today. I am so enthusiastic about my total failure because it makes something exciting happen. It makes the internet feel empowered to solve this problem and try it out. And I'm only excited to give it another try to come back with a solution, because there's no reason why we couldn't get this to work. Okay. I will see you guys soon, hopefully later today. A lot of you I know it'll be in the middle of the night when I come back. But everything will get archived, everything will be online, so you will get to watch it eventually. Keep in touch. I always love to hear feedback, positive, negative, constructive, kindness with negative feedback is always appreciated, and I will try to be in touch with all of you, okay? Thank you, everyone, and goodbye. I gotta go. I have exactly 12 minutes to somehow go get lunch and eat it and have office hours helping students with coding problems until 4 o'clock. Then I'll try to come back up here, get set up because I have a guest coming to record. Somebody's knocking at the door because I'm probably being too loud. Hold on. Yes. Hi, is it too noisy?
Yes.
And you're in the classroom next door there? Okay.
Sorry.
That's fine. No, it's good to know that.
Yeah, we can hear everything.
Okay. I knew that would happen eventually. You guys could hear that. Okay, I'm going. I'll come back later. Okay, goodbye.